Hello. Please write in the chat box if you can hear me. I'll just wait. Write in the chat box if you can hear me. Write in the chat box if you can hear me. Okay, aloha. Welcome to the epapa Ka Hana Unit 6 Online Professional Development. So we will start just real quick, just a really fast introduction to the project, and then we're going to go over the Unit 6 activities, and then we're going to talk about a 3D printer activity that we have. And it's a cumulative activity, so if you've gone through most of the books, then most of the book maybe until unit 4 or 5, then you should know, the kids should have enough to do the 3D printer activity. Okay, so let's go ahead and get started. So this is the epapa Ka Hana project. What we're doing is we're providing math content, like a math curriculum that aligns with the Go Math book. So we have the alignment and the pacing goes with the Go Math book, which is aligned with the Common Core state standards. We provide context to all the math content, but we don't provide drills. But in the last PD, we did show where we have drills on the website. And also the Go Math book has a ton of drills that will be useful. Cool. We also have a lot of forum questions where students from across the state can share their ideas and share their experience and reflect about where the math comes up in their life. We also make use of technology, not just with the online forum, but also with this online graphing calculator, and also with 3D printing, which we'll show you in a little bit. Okay, and that's it. Let's go ahead and start with Unit 6 activities. So we can go on stemforall.ning.com. Let me zoom in a little bit. Oh, too much. I mean, if you're, I'll wait a little bit for everyone to get signed in. Alright, so if you're at the website, please go ahead and go to the Unit 6 activities. We're going to go to our project. Then we're going to go down to Unit 6. And the first activity we're going to look at is 14.2. So in this activity, we're looking at scatter plot data. And then we're going to do a line of best fit and make some predictions with that line of best fit. Okay, so in this activity, we're talking about how the density of the human population affects the health of the fish population. So over here are some data that we have. So it's 100% fish health, there's 0% fish health, where the coral is dead and the fish are scarce. And over here is the density, humans per hectare. And we do explain that that's about as big as a football field. Okay, and then you can either apply it the old school way with some paper and pencil, or you can use Desmos.com. So if you go Desmos.com, let me do this again. You can go add item, go table, and over here you can put in the data. This is a free account. You can, so over here is 0, 5, 10, 15. 0, 5, 10, 15. And then y equals 100, 85, 75, 70. 100, 85, 75, 70. Cool. And it plots it for you. If you don't see it, you can roll the wheel on your mouse to zoom in and out. Or you can click on this wrench. This wrench changes the graph settings, so you can change the axes over here. Cool. You can extend the axis, or you can, I usually use projector mode when I'm showing stuff because it makes all the lines thicker and easier to see. Cool. So I'm not going to finish plotting all the points, just to show you. And the next question, we have to draw a line of best fit. So if you're using paper and pencil, I'll probably need a ruler to draw the line of best fit. If you're using decimals, you can just type it in. So if you know the equation, you can just go y equals whatever the equation might be. So I'm going to guess maybe 100 minus 2x. It's pretty good guess. If you don't know, you can even use this cool feature called the sliders. So if you just put mx plus b, then you have the option to add slider. So I'm going to add 2 sliders, one for m and one for b. Yeah. So you have these little sliders that you can change. So if I change m, this happens. If I change b, this happens. Yeah. So I want b to be way up here. So I'm going to change the range. So I'm going to make b go up to 150. I'm going to pull this up. Now I want to make the slope negative. So I'm going to drag the slope down. So that's a pretty cool feature. Okay, so I'm going to give you guys a couple of minutes to work out the rest of the problem. And then there's going to be a forum question. Well, actually, don't work out the problem in detail because there's some more stuff that I want to cover. But just kind of go through it until you've read the forum question. And then I'm going to come back and talk more about it. So go ahead and check out the activity up to the forum question. If you get to the forum question early, please go ahead and fill out a response for the forum. Okay, welcome back. So we're gonna go ahead and talk about the form. So in this first problem, the first part we're talking about how the population density is correlated to the health of the fish on the coast. And then the second part, we talk about stopping fishing and letting the fish recover. Well, actually, not just stopping fishing, but actually keeping the people away from the water. So over there, you also have to do a line of best fit and do some predictions with that line. And here's a forum question. So if you guys can, could you guys please put a response to the forum question? So over here, we're talking about how the ancient Hawaiians were able to take care of the fish population and their own population. And also, how can you take care of the ocean? Okay, so please go work on that, and then we'll wait till everybody has had a chance to add to this forum question. Thank you. Okay. Thanks a lot for adding to the forum. And we're gonna have to move on to the next activity. 'Cause I wanna honor you guys' time, but we will stay near the end for more questions. Well, and also you can keep writing stuff in the chat. And even though I'm talking about the activity, we have Greg and Justin here answering all the questions on the chat. So you can, yeah, if you have more questions, please go ahead and write it there. Okay, so next activity we're gonna go over is activity 14C, so the cumulative activity for module 14. So if we're at this page, let's go down to cumulative activity 14. And over here, it's more scatter plots. This one's a very straightforward problem. In this activity, you are trying to hitch a ride on a canoe to another island that's 175 miles away. Unfortunately, this character, which is you, have a habit of talking too much and being impatient. So in this activity, you're just nagging the navigator. You go, "Are you there? Are we there yet? What? No, bruh, we just started. Are we there yet? No, bruh, 171 more miles." And it just goes on and on. And this continues every hour for a total of 7 hours. Until finally, you say, "Are we there yet?" And the navigator says, "Bruh, be quiet. If you ask one more time, I go throw you overboard." And over here is the data that you collect before the navigator gets mad. Over here, you just have to talk about the association data, whether it's positive, negative, or there's no association. And then you have to fit a line of best fit and figure out the average speed that you're traveling at. And you use that to determine how long it will take to get to your destination. Yeah, so please go ahead and check it out for maybe 3-4 minutes. You don't have to finish all of it, just kind of take a look at it, and if you have any questions, please go ahead and ask us. Thank you. So, okay, so thank you for working on that problem. We're gonna move on to the next problem. That was kind of a straightforward one. Oh, okay. I saw some feedback. Yeah, we'll put a link for decimals. Okay. So, going on to the next problem. Let's go to cumulative activity 15. Okay. Let me go back to the beginning. Okay. This activity, we are talking about injuries that are sustained during canoeing. So we're just comparing we're comparing short races and long races and the rates of injury. And both this activity and the last activity, they're based on actual scientific research. So in the last activity, I did end up finding several research papers that found that the higher population densities, that they correlate with more damage to the coastal life. But I just I changed the numbers to make it a little bit easier to calculate, and also change some of the metrics. They use a little bit more complicated way of quantifying how much damage is done in the ocean. So I just changed it to fish health, and I just made a percentage from 0 to 100. And this activity is also it also comes from a scientific research where they looked at injuries from short and long-term races, and they found that the long-term races had a higher rate of injury, mostly like back and shoulder injuries. So in this activity, we're just gonna fill out these missing data using the given data. So it's kind of like Sudoku. Just fill out A, B, C, and D, and then you figure out you change it to the frequencies. And then if you type something here, like if I type 1, or actually, yeah, I'll put 1 for now. And then you go on the next page, it's going to move over all your answers from the last page. So over here, this is the one I wrote. So if I type Bob, for example, B-O-B, this is going to move the word Bob over. And over here, they have a chance to confirm if they like their data, or if they want to go back and change the data. And it gets moved over onto the next page. And on this page, they're just going to answer some questions using the tables that they filled out from the previous page. And there's a quick question over here. And in the end, we have the link to the research paper that saw this data. Okay, so go ahead and look at it for maybe 5 minutes, about 5 minutes, and then we'll come back. And you can ask some questions on the chat. Thank you. Hello. We have two critiques that we'll add on right now. Oh, well, we'll add on, but I'm just going to talk about it right now. Okay. So the first one is that you need to fill out this table in order to fill out this table. So it does make sense to finish this one first and then use it to fill out this one. So the critique was to have it filled out, to put on separate pages. Yeah, so you just focus on doing one, and then the website fills it in, and then you focus on doing the other one with the previous data that you put in. So we're gonna put that in there because we do agree that that would really help organize the data and take away some of the confusion from having all these letters everywhere. The second request was about having a calculator on the same page. Unfortunately, on this website, it's really hard to do to put on the same page. We could put it on another tab, like here. Well, some of them have multiple. This one doesn't. Some of them have multiple tabs. We could put in another tab, but that still doesn't help that much because you're still flipping back and forth between pages and tabs. But in the next website, we are redoing the website this summer, and that's one of the things we are trying to include. So one of the things is we're trying to include something in the background that allows the students to type math, so be able to type square root symbols and all kinds of stuff like that, and exponents. We're gonna include that in the new webpage, and then one of the things we're thinking about is trying to put like a calculator on the side, except for problems that are about approximating. So those problems, the purpose is to be able to approximate. So giving a calculator takes away from that. But in a problem like this, where the focus is not about being able to approximate numbers, we would want a calculator, and we're gonna try to put that on in the new website that we're working on this summer. Okay. Hi. Okay, so in order to honor you guys' time, I'm gonna have to move on to the final activity. But Justin and Greg will be on the chat if you guys have more questions. And also, we can stay a couple more minutes when we're all done with today's PD if you have more questions. Okay. So after the Unit 6 stuff, we also have this bonus activity, the 3D printing activity. That's one of the things we wanted to provide. We wanted to just integrate and introduce more technology into the classroom. So we wrote a 3D printing activity right here. We put it in Unit 6 because we didn't want people to try to jump into it too early and kind of get lost. So this is a pretty involved activity, and if you guys are interested, we can come to the classroom and help implement it for maybe 2 sessions or so. Yeah, just let us know, and we can try and work something out. Okay, so let's go ahead and talk about it. So if you click on the link, you should, where is it? Oh, sorry. There we go. Okay, so we have it as a PDF. The reason why we did it like this is because it's kind of a long activity. It'll take several days. It's a bonus activity, and it's gonna take several days. So we want the students to be able to document their progress, and a lot of the questions refers to previous answers. So we're just gonna do a kind of a quick run through of it. It's pretty involved. It's kind of too involved to go through in one session. But we're just gonna talk about the gist of it. So in the introduction, it's just gonna talk about units. So over here, this kind of basic metric and US customary units, so feet per second. The more confusing one is mass and weight. A lot of people think they're the same thing, and sometimes they're given the same units. And sometimes we do distinguish one as a troy pound as opposed to regular pound, and then or like a pound force, which is kind of a really weird one. But in metric, the units come out pretty nice. So even though most students are not familiar with the Newton, we figure it's a really good time to bring it up, because it actually works really nicely with the science. Also, the numbers come out nicer too when you're using metric. So over here is the difference between mass and weight. Mass describes how much stuff is inside something, and weight is a force describing how hard something is pushing down. So over here, these two trucks, one is on the Earth and one is in the moon. It's on the moon. They have the same mass because it's the same truck, but they have different weights. So the first part will be talking about units. The second part, there will be writing an equation describing how long the canoe must be to fit 6 people, 6 paddlers. So we have, so the paddler needs this much space and the ends needs that much space. And you can write a linear equation where the independent variable is the number of paddlers. And then from that you can figure out the length of the canoe. And you can choose the width, and that gives you the length of the canoe, the width, and we do not have the depth yet. And then the next activity will be determining the depth, well, the next 2 activities. So these are actually pretty long activities. There's like 5 parts to it, I think. And we expect them to take different days. Over here we are figuring out the volume of the canoe. In this example, we have a house. Basically, you can figure out the volume of the canoe by modeling it as a simple shape. So over here, we're modeling this house as a sphere, and we can calculate the diameter here. And I chose the sphere because I figure they probably wouldn't be using the sphere for the canoe, because the sphere is a pretty bad approximation of the canoe. So I just thought I'd use one of the shapes that the students might not use. So other shapes that might be better probably like a cylinder that goes down here, or maybe like a rectangular prism, or I can do a combination of rectangular prism and triangular prism or other stuff. So over here, if you do not know one of the dimensions, like if you did not know the height, then you can actually rewrite the volume as a formula where you're missing one of the parameters. So over here we have x as the height, as the depth of the canoe. Well, in this example, it's the height of the house. Okay. So why did we do this? The first part, we have the minimum dimensions of the canoe, but we're missing the depth. And basically we wanted, the first part was to tell you how big does the canoe have to be in order to have enough room for all the paddlers. The second part is to figure out how big the canoe has to be in order to float. And that's what the X is. We need to figure out how deep the canoe has to be in order to float. But in order to figure that out, we need to understand the physics of floating. And that brings us to Archimedes' principle. So over here is Archimedes' principle. So if you have a 7 Newton object and you put it in water and it sinks and 7 newtons of water spill out, or 3 newtons of water spill out, then the object actually becomes 3 Newton lighter. And that's Archimedes' principle. So here's another example where the object floats. If the object is 7 newtons out of the water and then you put in the water and it floats, that means the object went from 7 newtons to 0 newtons, which means that 7 newtons of water spilled out. In other words, it became 7 newtons lighter. So it started off at 7, you put in the water, it became 7 newtons lighter, and now it has 0 weight. And then the final part of it is to determine the mass of the team of paddlers. And from there you can figure out how much water displacement does the canoe need. So basically how much buoyant force does the canoe need to be in order to lift the mass of the canoe team. And then with that you can solve for x from the formula you came up with in part 2. So this will probably take about 4 class periods, or maybe 3. And you should end up with canoe that is both big enough so that the canoe paddlers can sit comfortably, and also is deep enough so that you have enough buoyant force to lift the canoe. So yeah, we know it's kind of confusing. It's a more advanced activity, and it's mostly for students that have finished most of the curriculum. And yeah, and we can help you guys with the implementation of this lesson if you guys are interested in this activity, and contact us. Okay, so let's go to the final part of this activity. In this final part, we will be scaling down the dimensions by 1/50, the scale factor of 1/50. And then at this scale, you should be able to, we should be able to 3D print it. So over here is a link. If you click on this link, you end up, oh, where did I go? Okay, let me click it. If you click on this link, you end up with this model, and then you guys sign in, make an account. So once again, if you guys are interested in this activity, we can come help this implementation. We can click copy and tinker, and you end up with this nice 3D model that one of our staff made. So Matsu made this. So here's our canoe. And if you click the canoe, you can change the dimensions to match the dimensions of the canoe that you designed earlier in the activity. So you can make it wider, you can make it shorter if you want, you can make it, oop, don't do that. You can make it tall or very shallow. And then once you've designed it to match the dimensions that you decided was appropriate for your canoe team, the last part, you can click on this drop box. You can save the model and then drop it off in this drop box. And then what we'll do is we'll download your model, and then we can print it with this 3D printer that we built. And we're going to also record the printing. And then we can come back on another day with the 3D printed canoes, and then the students can sand off the rough edges and then paint the canoe and design it however they like. So they'll all get one of these. Also, we'll be recording the printing, and we'll either send a video of a time lapse or we will give a link and a specific time where we'll be printing it, and then the students can watch it being printed live. Or we might do both. We have to figure out that technical part right now. Yeah, that's pretty much it. And then there's also it's supposed to be another part to this activity, but we kind of took it out. So let me show you what that is. So if you look at the canoe model, there's this little cylinder thing right in the middle. And what this is for is actually to hold a sail. And the original plan was to print this with this holder and then to put in a sail and then to blow the sail to make it move. And then after you blow the sail, the students can race it and then take statistics on it and ask some questions that come up in Unit 6, which is about statistics and two-way tables, and do some statistical analysis of the canoe and the sail. Unfortunately, right now the way the canoe is not engineered correctly. It's a bit unstable, so we took out that part for now until we can work out a design that stabilizes. So we'll probably put an ama, which is a outrigger, onto it to stabilize it, but we're still working on that. We're not sure where that's gonna go. Yeah, so that's kind of it. If you have any questions, let me know. So I'm gonna put up the question page right now. Yeah. Okay, so in order to honor you guys' time, we're gonna go ahead and wrap it up. But yeah, so that's it. This is one of the 3D canoes, one of the canoes that we printed on our 3D printer. Yeah, so thank you for joining us this evening, and we'll stick around for a couple of minutes if you have any more questions, and you guys can contact us by email if you have any comments or questions, or if you're interested in a 3D printer activity and you want us to come and help run parts of it. We're probably more helpful in the last part of it that involves the 3D printing. Yeah, and if you have any suggestions on changing the earlier parts, which is about the applied math part, please let us know. Cool. Well, thank you for your time. Have a good evening. We'll stick around if you have any questions. Cheers.